So today's lecture focus is going to be energy bar charts. Yesterday you worked a little bit on the energy skate park, and one of the things in the energy skate park that was kind of important was the little bar chart off to the left-hand side. That little bar chart showed the amount of energy that the skater had at different points in the ramp or hill or valley. Energy bar charts are also called LOL charts, in large part because it looks like an L, an O, and an L. But they can be used to illustrate a conversion of energy form within a system. And the way that we have this one set up here is we have some examples of energies that you might see as initially and how they might change finally after the experiment or the observation has taken place. So the energy bar chart rules, I made this acronym SCIFI, something like that. I don't know. Just trying to help out with remembering things. And the steps that you use when you're creating energy bar charts starts with S. You have to identify your system. G would be identify gravitational energy at its lowest. And sometimes gravitational energy might not be present in your system, but you still should identify if it's there or not. I would be initial energy. Also known as position A. F would be final energy, also known as position B. E would be if initial energy has to be equal to final energy in some way, shape, or form represented on the chart. And then lastly, you need to identify or write your energy equation. And that will be pretty easy. So we're going to go through a couple more slides, and then I'm going to go through a few examples. So first of all, there are a few things that you're going to see on these diagrams. One of the things that you'll see would be position A, also known as initial. You will also see position B. Maybe I should do it this way. So this would be position A, and then we'd have position B, which is final. You might also see velocity, which would be represented by a V. And you might also see a Y, which is height, like on the Y-axis. And then you'll also see these bars here, so this and this and this, which will represent motion. So on the graph down below here, the skater is moving, and that's how we know it with those lines. Here would be where you would see velocity. In position A, velocity is greater than 0, and in position B, velocity is final is less than velocity initial, so he's going slower. And then the last thing would be the height, which was, in this case, height is at 0, and at the final position, height is greater than 0, so it's higher. So these are some things that you don't necessarily have to write down, but you should probably think about when you're doing these graphs. These are qualitative descriptions, so we don't use numbers. The amount of energy is arbitrary. It's not really important. It's just the evidence of equality. That means, what that really means is that initial energy has to equal final energy when we're done. And so there's a couple different energy types that you have to remember. You're going to have to keep track of from now until the end of the semester for sure. So we have our kinetic energy, we have our gravitational potential energy, we have our elastic or our spring energy. Ooh, excuse me, sorry. We have electrical energy and we have chemical energy. Another big important thing that you should probably think about or keep track of is that if energy seems to disappear, that is, like an object stops moving, then that means that it's really identified for our purposes as dissipated energy. So if energy stops being present because the object slows down or the object stops, the energy has been dissipated in some way, shape, or form. And we'll get more into that later, but for the time being, you just need to know that if energy seems to go away, it's dissipated, because we can't destroy energy. Now, a couple of other things that you should be aware of is that these are some questions that can help you identify the type of energy in your system. So if the object is moving, we would say that the energy is kinetic energy. If the object changes height, even if it goes up or if it goes down, we would call that gravitational energy. If there is a spring or something elastic or being stretched present, we would call that spring energy. If the energy is going to be burned in some way, shape, or form, like fuel for a gas in a car or food in a human, that would be chemical energy. Is there electricity moving something, that would be electrical energy. And if there's friction or does the energy appear to be disappearing, we would call that dissipated energy. Okay, so we just have to always keep track. Now, here are going to be a few examples that we're going to work through, and we're going to try to talk through them the best that we can. Now, so here's the scenario. Initially, a green box is sitting on a blue table, and at the end, the box was knocked off the table and has fallen to the ground. So I'm telling you that the system includes the box, the table, and the ground. So the very, very first thing I'm going to do is I'm going to remember that my acronym SCIVI is going to help me. So the first thing I have to do is identify my system. And the problem tells me that my system is the box, the table, and the ground. So the system always goes in that circle. Now I need to identify all of the energy that's present at position A, so the first thing I have to do is identify G, which is where gravitational energy is at the lowest. And it appears to me that the gravitational energy is at the lowest here at position B. So gravitational energy is the highest at position A. And so since it stopped moving, that's really going to be important to consider. Now, so at this point, the next thing I need to do is identify my initial energy and my final energy. Well, because it's sitting on top of a table and it's going to show a change of height, we're going to identify that my initial energy has to be gravitational energy, and my final energy, because the object actually stopped, the energy disappeared, is going to be dissipated energy. So now I'm just going to choose a couple of blocks or a couple of bar lines in this bar graph to identify where the energy starts and where the energy ends. So my initial, I'm just going to give it 2 blocks to show that we have some energy, gravitational energy. And then my final, because it's going to dissipate, I'm going to have 2 more blocks because all of the energy is gone. The object has stopped moving. And that's as simple as these get. One slide just to write my energy equation over here again, which I should probably do. I'm going to say that E gravitational energy has to equal, in this case, E dissipated energy. A couple more examples. Initially a spring is launched and a purple car is, initially a spring to launch a purple car is loaded. That is compressed. At the end, the spring has sprung and the purple car is moving along the ground. So at this point here, we have a car that is moving at the end. So the first thing we need to do is identify our system. So it tells us that the system is the spring, the car, and the ground. Now, the other thing that it tells me is the car is moving. It doesn't tell me that the car is speeding up. It doesn't tell me that the car is slowing down. It's just moving. So we're really only focusing on a couple of things here. There is no gravitational energy because the car is not going up or down along the y-axis, so it's staying on the same axis, so we don't have to worry about gravitational energy at all. Okay, so now initial energy is this part right here, the compressed spring, and because it's a compressed spring, I'm going to say that it's spring energy. The final energy is the car moving, and I see that right here, so I know what my final energy is. So now I need to make sure that my energies are equal to one another, because the car is moving at this particular point in time. So I'm just going to go ahead and I'm going to give the spring energy a height like that. And then because the car is moving at this point, I am going to look at the kinetic energy, because that's where we're at, and I'm going to look something like that. So now the question is, what is my, shoot, I didn't do this the last time, so I should have, but what is my energy equation? Well, the energy equation is, since the initial position A has to equal the final, all I'm going to write is E spring, I should do it probably like this, E, the energy of the spring, has to equal the kinetic energy of the cart. So that's the energy equation. And if I go back, now, let's do the final example. Here we have a skateboarder rolling down a walkway and is about to jump off a ramp. System, gravity, initial, final, equal energy, energy equation. So, first thing I noticed the problem tells me the system is a skateboarder and the ramp. So skateboarder and the ramp. Okay, so check. Is there a gravity change? Well, I can see that there is some type of gravity change because the y initially is at 0 and now the y is greater than 0. So yes, there is a gravitational change, so that tells me that the skater moved up. Okay, and then the other thing I need to check is my initial energy. So at position A, velocity is greater than 0, so the skater is moving. So we've got a couple of things going on here. And then at position B, the final velocity is less than the initial velocity, and the skater is still moving. So because there is no change in, so I've identified my initial situation and my final situation. So here, all that's going on for my skater initially is he's moving, so we're going to identify that as kinetic energy. And here, he's still moving, so we're going to have some kinetic energy, but we're also going to have a height change, so we're going to have some gravitational energy. So those two things have to be represented here. Now, what's going to happen is that I'm going to identify in my bar chart that the kinetic energy is going to fill all 4 bars. And then that's all the energy that I have initially. Now, my final energy is going to be a little bit trickier. I do know that my kinetic energy is lower in position B than it is at position A, and as a result of that, I have to represent that in my graph. So I'm just going to go like this, which means that I still have to have, so at this point, my kinetic energy does not equal, or my initial energy does not equal my final energy. So I have to represent my final energy, and since the skateboarder moved up, I'm going to represent my final energy, or my gravitational energy, like that. So now when I go to write my equation, kinetic energy is equal to some kinetic energy, which is less than what we started with, and some gravitational energy. And that's our final equation. So we've gotten rid of all of those things. So that kind of sums up, or is how we use basic energy bar charts. Your homework for the evening is to do worksheet number 2, which is energy bar charts, and I believe there's 7 or 8 problems of them. Good luck, and we'll talk about it tomorrow.